Hi everyone, welcome to Man's Academy and welcome to lecture 3 of our ETAP course. I'm Mohamed Osman Mansari. In our previous video, we looked at how we can model a power system network in ETAP. In today's video, we will demonstrate how we can add ratings to the different elements on our previously modeled power system network. Without wasting time, let's get started. So this is our model power system network. So from CB1 to T1 and CB2 to T2, we'll add transmission line. So this is transmission line. So just click on it and bring it to where I want to place it here. Let's pick another one. Put it here. Let's just align this one. This one as well. I think the network is skewed to the left. Let's just center it. It is fine. So to open the power grid and input information, just double click on it. So for the ID, let's just say power grid. Connection is a three-phase connection. The service it's in means it's connected, and out means it's not connected. For the operating mode, this power grid is operating in a swing mode. The power grid basically contains the largest generator within the power system network. So for the rating, let's just say it's a 161 kV power grid. It's a balanced three-phase system. For the short circuit, for the three-phase, let's just say 1000 MVA short circuit, and the X by R ratio, let's just say 10. We'll actually define practical values when we shall be looking at short circuit studies, transient stability, and other studies within these two. For now, let's just click on OK. So you see that the information on this power grid has been updated, and you see that since this power, the rated kV of this power grid is 161, so this bus also is now 161 kV. So for CB1, we also double click on it to open it. For CB1, the ID we'll leave it as default CB1. Also, the service it's in, the status is closed. For the rating, you can actually define the ratings of the circuit breaker depending on the information that you have. But for this tutorial, I'll just pick a circuit breaker from library. Just click on library. For ABB, mind you, we are looking for a 161 kV circuit breaker. ABB can't provide that. Alstom, we have 141 now, it can work. GE, so Hundia, let's just see Siemens. Let's just use this 170 kV. Click on OK. You see that the information of the circuit breaker has been populated. So the rated kV is 170, rated 4000, and these are the information. For reliability and all those other stuffs, we'll look at it in subsequent videos. So since CB1 and CB2 actually are similar and they do have the same information, so we'll just copy this information from circuit breaker 1. To do that, just open it and then click copy data to default. Click on it and open CB2 and click this one which is paste to paste this information. You see that the ratings of CB1 are the same as CB2. All this information from circuit breaker 1 has been populated, has been copied to circuit breaker 2. Just click on OK. So for this transmission line, the ID also will leave it as default line 1. Service also in. The length of this transmission line, let's just say 2 kilometer. It's a 2 kilometer line tolerance. We leave it at 0. And for the parameter of this transmission line, we'll also pick a transmission line from library. Just click on conductor library. We have PLE. It's a metric system transmission line, and the frequency is 50 Hz. We also have 3 conductor types here. We have AAAC, we have AAC, and we have copper. So we'll go with AAAC, and we'll use neon 210 square millimeter with 19 strands. Just click on it and click on OK. You see that the information of this transmission line has been populated. So click on OK. What we'll do also, we'll just copy this information from transmission line 1 to 2. Just click on copy and also open let's open this. Let's open here. Okay, just paste it here. You see that the information of this transmission line also has been populated. For the configuration, we left out the configuration. The configuration type, we have horizontal vertical. This is vertical. The phases are arranged vertically, and the height of this transmission is just say 18 meters. And the spacing between the phases, let's just say 1.5 between each phase. The number of ground wire is just 1. And click on OK. So, and we also need to add the configuration. Do the configuration for this one also the same. So here also we have say 18, 1.5 between each phase. It's also arranged vertically. So number of ground wire is 1. And then click on OK. For transformer 1, when the transformer steps down the voltage from 161. Let's just say from 161 to 33 kV. So open the transformer. The same information here for the rating. Let's just say the secondary voltage, let's just say 33. And let's just say it's a 10 MVA transformer. You see that the full load current for the primary is 35.86, and for the secondary is 175 amps. So for the impedance of this transformer, I'll just pick typical values, typical Z and X by R, typical X by R, and also this one typical values as well. So click on OK. So what we'll just copy this information from transformer 1 to transformer 2, do the same, copy, and we'll just paste here. You see that the information also has been populated as 10 MVA. Click on OK. For CB3, and the CB3 is now should be a 33 kV circuit breaker. So just click on rating as well. Just pick 30 kV circuit breaker from library. Let's just see ABB also can provide Alstom. We have this. We can use this 36 kV circuit breaker. Click on OK. We'll just copy this information. Just click on OK. Copy this information again. Paste it here to circuit breaker 5. Click on OK. And since all the circuit breakers are 30 kV circuit breaker, we'll just paste the same information. Paste here. Click on OK. This one as well. Paste. Okay, this one again, paste. Okay, and let's just align it. It's fine. For cable one, let's just say the length of this cable is 100 meters, and the rest of the information will pick it from the library. Let's just use this one. AKB 100 EPR BS6622 magnetic cable with the size of 120. Click on OK. Click on OK as well. We'll do the same for cable 2, also 100 meters. Also pick this 120 and then OK. And then OK. For the loads, these are lump loads. Let's just open it. So let's just say load 1. And go to nameplate. That is 30 kV load. Let's just to define the parameters of this lump load. Let's just come to calculator. So let me just say I need 5 megawatt load, and the power factor, let's just say 85% power factor. You will now see that 5 megawatts load active power will give you a 5.882 apparent power, and the current of those loads is 102.9 amps. So just click on substitute so that you can actually populate those informations here. I think for the load type, constant kV, constant Z, in subsequent video we'll delve into more of how we can design these loads. But for now, I'll just click on OK. For load 2, let's just say load 2 here. 2. Just go to nameplate again. Go to calculator. Let's just say this one will need 8 megawatts. The power factor will only 100%. It's impossible in a practical network to have 100% power factor. So we'll just say 85. And here the MVA will be 9.412. And the amperage is 164.7. Just click on substitute so that it is populated here. So click on OK. So basically this is how we add ratings to the different elements of our model power system network. In subsequent videos, we'll look at how we can perform load flow storage, circuit analysis, transient stability analysis, and other studies within the ETAP tool. Thank you for watching, and hope to see you in our next video.